So good evening, guys. So hope you are able to hear my voice and see my screen. So today we'll be, focusing on the questions which are asked in the year 2016. And my name is Praveen, and let's get started with today's session. So in the year 2016, so there were around 10 questions,
You
out
are
of
currently
which
the only person in this conference.
five questions were 1 mark, and the other five questions were 2 marks. So totaling to say 15 mark. Okay, so this year, the gate questions were pretty easy compared to the last year. So nonetheless, you have to be prepared at all times. So let's get started with the first question of today's class. To take this problem, the damping ratio in fugite motion for gliders is usually less compared to the powered aircraft because. So we have four options. Gliders are unpowered, gliders are light, lift to drag ratio is higher for gliders, gliders fly at low speed. So let's try to do this. Pretty simple. So damping ratio. So recall, so damping ratio is basically 1 by root 2 times, CL by CD. This is what is the expression, okay, for Fugate mode, okay. Which means, if I try to increase CL by CD, what happens? That results in a decrease in the damping ratio, right? So Xi is the damping ratio, so please be careful. The damping ratio is less, which means the lift to drag ratio is higher. So which means that the lift to drag is higher for the gliders. Right? So they are basically gliders are basically designed such that your aspect ratio is higher. So you can just write in a glider, aspect ratio is higher. Okay. So this is the case. Okay. Right. So hope you guys don't have any doubts in this, right? So if no doubts, then let me go on to the next question. Okay. Pretty simple problems. Okay. Right. So during an aircraft cruising flight, the altitude above the ground is usually measured using. So we have four options: dynamic pressure, static pressure, radar, lesser range finder. So altitude above the ground. Okay. So let's say this is my mean sea level. Let's say this is the altitude which that is of interest to me. Okay. How would I determine that? From the hydrostatic equation that now the pressure decreases, right? So let's mark the pressure variation like this. The pressure decreases linearly, so which means your static pressure decreases, right? So the static pressure decreases as height increases. Okay. So that decreases. Okay. So which means what? So basically, by measuring the static pressure, I can simply determine the altitude, right? Dynamic pressure can be the same, like I said, if you recall our expression. So half rho naught v equivalent square is equal to half rho v true airspeed square. This is the equivalent airspeed. This is true airspeed. Okay. So we know the time pressure has to be equal, right? At altitudes. And radar, it's usually used for detecting objects by using radio waves. Okay, so that doesn't come under the detection of altitude. And laser range also doesn't come under. Okay, basically these two are used for detecting, any airborne objects flying. Okay, this is what is the case. Okay, hope you guys don't have any doubts on this. Then let's go to the next question. Indicated airspeed is used by a pilot during. We have four options: takeoff, navigation, setting the engine RPM, setting the elevator angle. Again, it's a pretty simple problem. So just its answer is takeoff, because indicated airspeed is basically the speed, which is shown to the pilot. It's indicated on the meter. Okay, so that's like a little bit of theory, right? During takeoff, excuse me, sorry for that. So during takeoff, comma, the pilot uses the indicated airspeed to determine when the aircraft has reached its rotation speed, which is the speed at which aircraft can lift off the ground. Right, so indicated airspeed is usually used by the pilot during takeoff. Okay, so there shouldn't be any doubts in this. Okay, right. So let's go on to the next question. The pitch angle and the angle of attack for a fixed wing aircraft are equal during. There are four options again: wings level, constant altitude flight, unaccelerated climb, unaccelerated descent, landing. Okay, so let's see. Let's see each and every option. So let's take landing. So pitch angle is basically the orientation angle. So let's say this is a pitch angle. Let's say this is the uh, wing is set like this. This is the horizontal. So this total angle will be the pitch angle, whereas if the relative wind is coming like this, so this will be my angle of attack. Okay, this is the key. Okay, so let's take landing. So in landing, this need not be same, because your aircraft is approaching, your angle of attack can vary basically, right? An unaccelerated descent, let's take a descent, very strong case of descent. So for this case, your angle of attack can be zero, but still there is some pitch, okay, to it, right? So which means you can't have this descent. Same goes for this thing as well. So which means we are left with this option of wings level constant altitude, right? Which is true because he has emphasized on the word wings level, right? Wings level means wings are level with respect to a reference, okay? That reference is the horizontal, okay? So at this case, your pitch angle, angle of attack, both will remain the same. Even if the relative wind is coming like this, this is V infinity and this angle is alpha. Hence, your pitch angle and angle of attack will still remain the same. Okay, let's say pitch angle with theta. In this case, alpha is not equal to theta, and in this case, alpha is not equal to theta. Where your theta is this pitch angle. Let me just write that down. Angle of attack is alpha. Okay, so hope you guys don't have any doubts in this, right? Again, simple thing. So let's write a little bit of theory in this. So just write pitch angle and angle of attack for a fixed wing aircraft are equal when the wing's chord line is parallel to the flight path, which is the level constitute constant altitude flight. Okay. What I explained is given in words. Hope that makes sense for you guys. Okay. Right. Let's go to the next question. If no doubts, the load factor of an aircraft turning at a constant altitude is 2. The coefficient of lift required for turning flight as compared to the level flight at the same speed will be same, either or half or double or 4 times. Okay. Right. So let's do this pretty simple again. Let me just underline the key components question is load factor at turning. Okay, constant altitude is 2. Okay. So we know that he's comparing with respect to level flight as well. Okay, so we know that, this, right? We know that during level flight, you can say that the load factor is basically the lift to weight ratio, right? So which is basically in level flight, we know, in a straight and level flight, L is equal to W, right? Which means what? Your N is equal to 1, correct? Therefore, L equal to W. But during the turning flight, let's write that. So we know that, it is basically your N, which is equal to L by W. This is given as 2, correct? Right. So let's keep that as such. In a turning flight at a constant altitude. Let's keep this lift as some L dash, So this, which means I can write the L dash as 2 times W, but W is basically L. So if I substitute that, L dash will be equal to 2 times L bracket this. So which means what? L dash is what? Half rho V square S times C L dash is equal to 2 times half rho V square S times C L. Okay. So half rho V square gets cancelled, S gets cancelled. So I have what? CL prime is equal to 2 times CL. So which means you can see that in a turn it is basically twice that of this SNL. So which means in SNL it is basically half of that. Right. Oh, you guys understood this, okay? So it should be this thing. Coefficient of lift required for turning flight as compared to a level flight will be double, okay? Hope you guys understood this, right? Because if I go back to the problem, so this is the lift coefficient required for turning, right? So you can just write the L prime is lift in turning, and the L is lift in a level flight. Okay. Hope you guys understood this. Pretty simple problem, isn't it? Yes. Okay. So if no doubts, then let's go to the next question. An aircraft is flying level in the north direction at a velocity of 55 meters per second under crosswind from east to west of 5 meters per second. For the given aircraft, Cn beta is 0.012 per degree and Cn delta R is minus 0.0072 per degree, where delta R is the rudder deflection and beta is the side slip angle. The rudder deflection exerted by the pilot is dash degree. Let's do this again, a simple problem. So this is the first question, I think, which they asked by using the rudder directional concepts. Okay, let's do this. So let's try to break this question. Okay, an aircraft is flying level in the north direction. Okay, so this is the north, and he says that under a crosswind from east to west. Okay, so this is 55 meters per second. Crosswind is from east to west, which is 5 meters per second. So which means now this will be the resultant velocity of the vector. Okay, resultant velocity vector. Okay, is inclined. Now this is the side slip angle beta. So just write that. So beta is my side slip angle. Right. Right. Next. Now what else is given? For the given aircrafts, let's write that down. Cn beta is 0.012 per degree and Cn delta R is given as 0072 per degree. Okay, right. So which means now let's calculate side slip angle from this. Okay, but before that, let's write the general expression for Cn is basically what? Cn beta times beta plus Cn delta R times delta R. Now to know make sure that the black now coincides with the red. You have to deflect the rudder, right? So which means the net coefficient has to be 0, correct? So which means what I can write this as Cn beta times beta plus Cn delta R times delta R will be equal to 0. So simplify that, what do I have is it is 0.012 times beta plus minus 0.0072 times delta. Okay. This is equal to 0. So what is beta? From this I can get the beta value, right? So I can write tan beta as what? Because it is a second quadrant, so mind you, this is minus 5 by 55. Okay. Which means my beta is tan inverse of minus 5 by 55, which should give you a value of 5.77 degree. Okay, let's bracket that. Okay. So now, having done that, delta R will be easy to determine. Okay, so substitute this. Okay, let's write. Substitute beta in. Let's mark this as equation number 1. Mark this. This is let this be equation 1. So which means what I will get delta R as. So it should be minus 5.77. So mind you, if you simplify this, you will get delta R as minus 8.66 degree. Bracket this. So this is the answer. So it is minus 8.66. Okay. Pretty simple, isn't it? Right? Okay. So let's go on to the next question if no doubts. Take this problem. An aircraft weighing 10,000 Newton is flying level at 100 meter per second and it is powered by a jet engine. The thrust required for level flight is 1000 Newton. Maximum possible thrust produced by the jet engine is 5000 Newton. The minimum time required to climb 1000 meter when the flight speed is 100 meter per second is dash. So what is asking is the minimum time required to climb. Okay. So let's do this pretty simple again. So let me write the given data first. So the given data is the thrust required, okay, which is 1000 Newton, and the maximum thrust, which is thrust available, is produced by the engine is 5000 Newton. It's the max, and he's saying it is flying level at 100 meter per second, okay, so which is the V is 100 meter per second, and he says the minimum time required to climb 1000 meter, okay, so the height is 1000 meter. So which means from here to here, let's say you are now traversing this direction. So which means the height is now 1000 meter. Right. So from here you are going, okay, like this. So what is the time required? Right. So let's do this. First, let's determine the rate of climb. This is my rate of climb. Excuse me for the background disturbance. Right. So rate of climb is basically what? It is t minus d by w times the velocity, right? So which is basically the dh, rate of change of the height, right? So this is the thrust available minus drag is the thrust required. Substitute that, so we'll have what? So this 5000 minus 1000 divided by is the weight given 10,000 times the velocity, which is 100. Okay, so we'll have a value. Okay, so let's simplify this. This gets cancelled. So 4000 by 100 is 40 meters per second. Okay, so this is the rate of climb. So which means I want to climb 1000 meter, right? So which means what is the time? Time is basically this 1000 divided by 40 meter per second, correct? Because this 1000 is the height and this 40 meter per second is the vertical velocity. Okay, like if I just try to draw it in a much clearer way, this is the 1000 meter and is traversing upwards with the speed of 40 meter per second, which is the rate of climb. So this will give you a value of 25 seconds. Okay. Hope that makes sense to you guys. Okay, pretty simple, isn't it? So the answer is 25. Okay. So if no doubts, then let's go to the next question. The aircraft velocity components in body axis are given as UVW equal to 110. The air velocity, angle of attack, and side slip angle that order are. So we have four options: 120.1.1, 100.1.1, 100.995, 0.15.73, 100.995, 5.71, 5.68. Let's do this. Again, it's a very simple problem. So let's determine the magnitude of the velocity vector as seen in the previous session. So it will be what? 100 square plus 10 square plus 10 square. Simplify that, you will get a value of 100.35 meter per second. Now I know that is asking the air velocity and angle of attack and side slip. So first let's determine side slip. I know the vertical component or the v velocity. Let's not use the term vertical. Let's use the v velocity. Is basically the modulus of the velocity vector times the sine beta. Right? Which means if you simplify this, so I have 10 equal to 100.35 sine beta. So determine beta. So beta will be sine inverse of 10 by 100.35, and you will get a value close to 5.68 degree. Okay. Let's bracket that. Next is asking the angle of attack, right? So what is the angle of attack? So I know that from tan alpha, it is basically W by U. Okay. So this is basically what? 10 by 100. So from here, get the angle of attack. So angle of attack will be tan inverse of 1 by 10. That turns out to be 5.7 degree. So if you go to the options, so 5.68 and 5.7. No? So this is the velocity. Okay. Right. So but just check this value. I think I made a mistake in here because just agree with 100.995. But nonetheless, you can just check it out and let me know. Okay. Right. Even if it's wrong, so but the other values are only agreeing in this in here. Okay. So if angle of attack is 5.7, this is 5.6. It's only option that is applicable is this thing. Okay. Fine. So if not also, let's go to the next question. Please, solve questions, so that helps you prepare well for the actual gate exam. Okay. So please take these questions and the test series very seriously. Okay. So this is somewhat a tricky question. The Dutch roll motion of the aircraft is described by the following relationship, where the air matrix and the delta beta dot delta r dot, the dynamics is given by the change in the side step angle and the rate. Okay. The undamped natural frequency and the damping ratio for the Dutch roll motion in that order are. So we have four options. Let's try to do this. Again, a simple problem. So let's write on the matrix first. So what is the matrix? It is basically minus 0.26 minus 1. I think you have a 4.49. And what else? Minus 0.76. So this is our matrix, isn't it? Okay. Let's keep that. Right. So let's simplify the roots first. Okay. So let's uh, take out the characteristic equation. Okay, so what I have is lambda I minus a will be equal to 0, correct? Which means I will have what? Lambda plus 0.26 will have 1 minus 4.49 will have a lambda plus 0.76, and this is equal to 0. So let's determine the roots of the system. So I'll have what? If I get the determinant, so I'll have lambda square plus this will become 0.26 plus 0.76, 1.02. You will have this thing plus you will have 2 lambda. Then what else you have is uh, so we'll have plus 4.49, and this thing will give you value of, if I'm correct, plus 4.68 equal to 0. Let me just do this again. So I have lambda plus 0.26 times lambda plus 0.76 plus 4.4. Yeah, so this is the case that you will get, right? Okay. If you solve this, let me just check the signs if I'm correct. Yeah, okay. Now if you solve this, so this is if you compare this, so lambda square plus 2 psi omega n lambda plus omega n square equal to 0. This is the general equation, okay? Which means you have to compare this with this, okay? Just write compare. So I have what? Omega n square is 4.68 and 2 psi omega n is 1.02. So from here get omega n. Omega n would be what? It is root of 4.68, 2.16 radians per second. Let's bracket that and substitute over here. You will get the xi as 0.235. So now if I go back to the option, so the one that closely matches is this option C. Okay. Hope you guys understood. It's pretty simple again, isn't it? When they ask a matrix type of questions, by default try to take the roots of determine the roots of the system, and then can just use your thinking and then arrive at what is asked in the problem. Okay, right. So if no doubts, let's go to the last question of today's session. Again, this is a very simple problem, but remember that the question is humongous in nature. Okay, nonetheless, let's do this. A glider weighing 3,300 Newton is flying at 1,000 meter above sea level. The wing area is 14.1 meter square and the air density is 1.23 kg per meter cube. Under zero wind conditions, the velocity for maximum range is dash. So you have a series of data. So what he is asking is the velocity for maximum range. Okay. A glider, it is weighing 3,300 Newton. Let's do that. So he's asking, maximum range, okay? Velocity for maximum range. So for maximum range, if you recall, from the range formula, is the height. This is the so I have this expression of R is equal to H into CL by CD. Okay. So for the range to be maximum, CL by CD has to be max. Okay. So which means if I go back to the table, look at the values that are given over there. So which is the maximum value? You have 16, 20, 22, 24, 25.7, right? So that is my maximum value, okay? And the corresponding value to this is 0.9. Okay? So let's take that. So you can just write from the table CL by CD max is 25.7 and CL is what? Is given as 0.9, right? So with the 0.9 you get the velocity. How would you get that? It is basically under root of 2w by rho SCL times a cos gamma because it is in glide, right? So simplify that and you have this CL by CD, right? From here get the tan gamma. Okay, let's do that first. Okay, just right. We need this is the gamma value. Okay, gliding value. How do you get that? How to get it? So I know that tan gamma is 1 divided by CL by CD. Okay, so from here you get the gamma. Okay, you will get some value. Let's keep that as such and substitute that with the velocity and you will get the velocity as 20.55 meter per second. This is the velocity with which the glider has to fly so that it achieves maximum range. Okay. So I just write that in the blanks 20.55 meter per second. Okay. Fine, guys. I hope you don't have any doubts in this. So with this, we wrap up today's session. And if you like the sessions, please subscribe to our channel so that it will be helpful for us to create new sessions like that. That motivates us to do it. Okay. Fine, guys. So let's wrap up here and see you guys in the next class. Bye bye. Have a good day.